at algebra rules, and we're going to focus on isolating variables. Very, very basic. Okay. So our very first example, we have n. N represents some unknown number, so we don't know what it is, but we use a letter to represent it. Okay. And it says that this unknown number plus the number 3 is equal to 8. Now we might be able to mentally do something like this, but what we're going to do is we're going to isolate the n value. Okay.
Okay.
Let's get her. Because we have addition, what we want to do is we want to get the letter n all by itself on the left side. Okay, and when I say the left side, think of the equal sign like the middle. Okay, so this is like balancing the equation. So I want n by itself. So it means we have to move this positive 3. Okay, and what we're going to do, okay, so think of it like when you're adding, subtracting fractions. What we have is we have two sides of an equation, and whatever we do to one side, we have to do to the other side. Okay? So, how do we get rid of positive 3? Or what would be the opposite operation of positive 3?
Minus 3.
Minus 3. So, on this side, we're going to have n plus 3. Okay, we still have our equal sign. We bring that down. And I've made some room because what I'm going to do is I'm going to subtract by 3 on this side. Okay? And then, because we did that on the left side, we have to do that again on the right side. Okay, so what do we get when we do this? What is positive 3 minus 3?
0.
0. So think of it like it cancels out or it creates a 0. We don't really need to write 0 in, but now n is the only value left on the left side. Okay, and what is 8 minus 3?
5.
5. So if I replaced n with 5, is 5 plus 3 8?
Again.
So let's say I took this number 5. What this says is n is equal to 5. So what that means is, whoa, if I go 5 plus 3, does that equal 8?
Yes.
All right, so it checks out. So using that knowledge, in this one we want to isolate for our x value. Okay, we want x by itself. What would be the opposite operation of subtracting by 4?
Multiplying by 4.
Think of multiplying and division together. What would be, what two operations go together with subtraction, and what would the opposite be?
Addition.
That's right, addition. Okay, so if I have x, subtract 4, okay, and what would get rid of our negative 4? What did you say? Addition?
Yeah.
So we're going to add what value?
Positive 4.
Positive 4. And because we did it on the left side, where else do we have to do this?
On the right side.
That's right. On the right side of what? What are we referring to? What's this thing in the middle
The
here?
equal sign.
That's right. Okay, good. So, on our left side here, what is negative 4 plus 4?
0.
0. So they kind of cancel out. And we're left with x is equal to, what's 10 plus 4?
14.
All right. So, with that information, if I replaced x with 14, is 14 subtract 4 equal 10?
Yes.
All right, checks out. So this is a way, in math we call it algebra, to isolate, to represent something that's unknown. Here's some harder ones. 20 times q. Okay. Same idea, we want q by itself. Q by itself. So, what would be the opposite operation of multiplication?
Division.
Division. Okay.
1.
Okay, so let's divide, and we're going to divide by the value on the left, 20. Okay, and whatever I do to the left side, I have to do to what?
The right side of the equal side.
That's right, so we're going to divide this by 20. Now, this is a little different in math. You might need a calculator. Let's see, what's 20 divided by 20? Do you know?
20 divided 1.
1, very, very good. So, I'm going to write this in because I want to show you this step. It becomes a 1, so we have 1 q. So q is not technically by itself, okay? 1 times q is still left over. Now on the right side, we will use a calculator quickly because this is not a nice round number, but let's go 30 divided by 20. We get 1.5. Okay, so we know that 1q equals 1.5. So we have to multiply 1 times q. What is 1 times q?
1 times...
Hard idea. What's 1 times 3?
Oh, it would still be 1.5.
Well, let's think about our 1s. You're right, this will be 1.5. What's 1 times 3?
3.
What's 1 times 5?
5.
What's 1 times apple?
Apple.
Exactly. So what would 1 times q be?
Q.
Q. So we can kind of drop that 1. Okay. A lot of times they say canceling out, but we don't need it. So in other words, q is equal to 1.5. So just like before, if I replaced q with 1.5, 20 times 1.5 would equal 30. So this is how we would isolate it. Okay. And finally, this one's a. A divided by 5. What would be the opposite operation of division?
Subtraction.
Not subtraction.
Oh, sorry. Multiplication.
That's good. So on this side, we're going to multiply this side by what value?
Also,
Well,
5.
Yeah, that's right, by 5, which means we have to multiply this side by
5.
Good. Okay. What happens when we have 5? And look at this. It's set up the same way we were at 20 over 20. This now looks like 5 over 5. What does that become?
25.
This is like 5 divided by 5. Sorry, 5 by 5 would be 25. That's right. What's 5 divided by 5?
1.
1. Okay. And do I need to write 1a? Is that important? If I write that 1 in front of the a, what did we discover over here?
That it cancels out.
Yeah, the 1 we don't really need, so we can just write it as a. Okay? So I'm going to read this here as 10 times 5. Pretend we hadn't figured it out. A is equal to, what is 10 times 5?
50.
50. So would, in our original question, 50 divided by 5, would that equal 10?
Yes.
That would work. Good. So those are all the basics to isolating variables using algebra.